So, my congratulations. It's day number one from this event sessions built with AI, and our first speaker with such crucial, such important topic as accessibility. So, we have a truly inspiring session on how AI can make a real difference. Please welcome our first speaker, Prajwal Kumbar. Prajwal will show us how Google Cloud Service, especially Vertex AI, can be combined to create powerful, accessible technology. It's super interesting and exciting topic. So, you are welcome. Let's start.
Thank you, Anna, for hosting me on this platform, as well as this is my first international talk, and I'm super excited for it. And yeah, thank you. So I'll start with my introduction first. So myself, I'm Prajwal Kumbar, and I'm an AI expert working with Alpha Sites, where I build prototype or also some sorts of cookbooks for the clients. So yeah, coming to this session, I want to just show how AI is emphasizing more on daily use cases. So basically, to be precise, this project was done in Vertex AI Sprint, which was hosted by Google developer teams. So yeah, I'll be starting with the slides. We'll see how I had implemented or how it is basically taken over into the development phase and all. So let me begin with that. Yeah. So the basic idea of this was to help the people who were visually impaired. So the people who couldn't see the world, what actually it was. But with the help of AI, I built a product where an AI can assist a visually impaired person to move from one place to other place with full freedom, with all his liability on the gestures and all. So yeah, let me show the things next further. So coming to the statistics, why I took this project this serious is that we know we have 8 billion people in world. So around 8 people billion in world, we have 2.2 billion of population who are blind. That means it is totally 1 in 4 people in globally are visually impaired. So you can see this sector where AI can be helping the people to use this AI feature as their daily life, making their life go easily and all. So and also it makes 27% of world population, right? So 1/4 of the world navigates completely in darkness. As we saw these stats, it says that 1/4 of the world is totally moving in blind world. So how about taking this AI, using AI and helping people, right? So let's move on. So nearly it is 340 million people who are moderate to complete blindness. So now technology assistant isn't just convenient, it's life changing, right? So I'll be showing a demonstration how I had built it and basically how it is working, right? I guess even the audio will be visible.
Turn slightly to your
Yeah.
right and continue forward slowly. The path seems clear for several steps. Be mindful of potential obstacles just beyond the table. Additional context. Thinking face. The room feels like an open area, but it's difficult to determine the exact layout at the moment. Keep your head oriented towards your right to maintain spatial awareness. Let me know if anything feels unclear or if you encounter any further obstacles. Attention, asterisk. Warning.
Yeah, this was just a demonstration where we could see that how it is actually guiding us in moving the path, right? It is saying to take a slight right. We can see a empty space room, so we can move towards right. And it was made by few of the gestures or the parameters what I had done. I'll be discussing that in further slides. So I guess this was audible for you also, I guess. Mm, if I could get any response in chat. Yeah, thank you, thank you. So I guess this was pretty much clear that what actually how we can use Vertex AI. Means I'm not deep diving into development part yet, but you got the clear picture what actually how it actually worked in real world. To be honest, I did this in my home to keep it raw video so that how an user can also get a good helpful product in home as well, using that in home and just guide it. So okay,
Turn
I'll
slightly
be
to your
moving
right and
further.
continue forward slowly.
So also, if you have come across Google I/O, right? In Google I/O, the same project was showcased, and to be to say that this is my fourth project where my projects are being displayed on, not my project but my visionary project have been displayed on Google I/O for 4 consecutive years, and this is one of my, I could say I'm proud of that. Whatever I'm building with a reason and with a vision. That let's see how Google was showcased this project on the this platform. Yeah.
It's exciting to see these technologies powering new experiences in products like Search and Gemini, and also coming together to help people in their daily lives. For example, we recently partnered with Ira, a company that assists people in the blind and low vision community to navigate the world by connecting them via video to human visual interpreters. Using Astra technology, we built a prototype to help more people have access to this type of assistance. We're getting ongoing feedback from users, while IRA's interpreters are actively supervising for safety and reliability. With this and all our groundbreaking work, we're building AI that's more personal, proactive, and powerful, enriching our lives, advancing the pace of scientific progress, and ushering in a new golden age of discovery and wonder.
So yeah, as we saw that they have partnered with Astra, right? So Astra was a company where they were working on AI with visionary products. So this was a prototype where they showcased that yeah, this is how AI is getting into the real world. So why not let's build something which is helpful for users or for ourselves. So as we are talking about build with AI, right? So why not thinking in some visionary way, right? So now I'll be starting with the development part, whatever I had done, and these all things. So
It's a
yeah, the key features, whatever I had implemented over there was real-time hazard detection. So what is this? So basically, I had made a three-layer protection, priority queues, basic priority system. So where first was it used to detect object within 1 meter to 2 meters, where then it was like 3 meters to 6 meters, and then it was 6 meters to further. So we used to get an audio gesture based upon that level one, level two, level three. If it was between one and two, it used to say it is very high priority. So please stop and take further right or left according to the visible whatever it has guided it. And right, so these real-time hazard detection and depth precision are both same thing. So we are seeing the how much the object is in distance, right? So these both are the same features interlinked in a same class. So I'll just show the code in further things. So and sense understanding. So what is this? So as I shown the video of my house, right? So it said that it is an empty house where the right part is clear. So how I'm doing this? I had written a prompt where it used to send directly to the LLM. Basically, I was using Vertex AI Gemini Pro over there to do this. So basically, this is what contextual awareness and environment gestures it used to get and give the audio response. So, and priority based audio gestures. As I said, if it was like 1 to 2 meters, then it used to say high alert and all. You could see the whenever it saw a door, it gave a red box over there. It detected a red box that it used to say. Basically, it describes that there is a huge body coming in front. So yeah, that was very short video, but if I clearly show it in real world, then yeah, it used to work like that. So these are the four key features. And next, moving on to the next, safe path navigation. As I said, when it saw the right path is clear, so it used to detect and give us the safe path navigation. And motion trajectory analysis. What is this? That let's suppose a car is coming from front, so it is also having an object motion detection, that how fast is object heading towards the person or the camera. And context aware guidance, it used to think. It also has a feature where it has a memory, stores a memory what I had seen before and whatever gestures had given before. So let's suppose a person is going and he gets a wall further. So now the model can think that there was no object before, and before 2 to 3 meters, and the right side was clear. So it can say that go back, go 2 to 3 steps back and take right. So this is what context our guidance class was doing over there. And customize hazard weights. Basically, it used to detect obstacles like whatever. So this is all about how I'm handling the edge cases right now. Right. So you can see the basically mind graph or whatever the thing says, how I'm flowing into the posture. So basically, I'm getting the captured image, object detection, then I'm getting into depth evaluation and object prototyping, these all things. And then I'm going into basically if it has an emergency, if the object is too nearer, then yes, then what step I need to do. And the final thing is audio gesture. So yeah, this is the I've removed out the remaining part. Whatever you can head over to my GitHub later. I'll be giving the link over the slides. But yeah, these are the five, six, yeah, six different features. Basically, the classes you can say. Yeah, I had written it in a short to just understand like object detection and estimation depth classes like this, or these are the things whatever I had implemented. This is short code snippet, right? How the workflow is going on, what is happening in um, code, in what is happening in code. So yeah, as I said, like immediate threats, right? So if it is analyzing immediate threat and guidance priority, these all things. Yeah, this is the thing where prompt guide was. Yeah, I know that this might be a very less prompt, or it is not an agentic flow as such. I'm still working on it, but yeah, this is doing a pretty much good job, whatever it has to be done. And to be honest, this is more about having domain knowledge. So putting domain knowledge in this is we need someone like SMEs for that domain and get insight from them. Right? So you can see that thinking process, whatever I had written over here, right? These are the 6 steps, whatever I have given here for prompt guiding. And let's talk about tech stacks. So for basically capturing the image, I had video, it was OpenCV and Google Cloud Vision API. So why Google Cloud Vision API? You know, if what if I'm doing that all on my local, right? And my model is very if I try to do that on local, then my model can't handle it on my system. So there would be a latency of giving the response. What if the car is coming or some bus is coming from front, and it gives me the gesture after 10 to 15 seconds later, and then you might crash into that bus or that car. So when I'm using Vision API, that then it is all happening on a server where it is happening all on real time. It gives within fraction of seconds, right? And for AI decision engine, I'm using Gemini Pro, as I said already before. And for audio, I'm using Google Cloud Text to Speech API. Why text to speech? because my model is giving response in text and then converting it into, because Gemini Pro is converting that, is giving response in text and then giving it in basically speech, right? So yeah, for data processing, why NumPy and Sky5, you can just, I'll show the code right away. Yeah, I'll show why NumPy. I'm calculating the depth and all using NumPy. Yeah, so you can see the mind graph of how the tech stack have been implemented. Like camera is getting that is accessed by OpenCV, and OpenCV is that next it is going to Google Cloud Vision API, and then I had an object detection class in the code that is getting prompted with Vertex AI Gemini Pro, and my depth precision and all is calculated by NumPy, and the thread queue, basically this is for quota, like LLM quotas. We have quotas. We can't send more requests on a per second, right? So for that, I had wrote a code for queuing system, and the answer was coming out with text to speech. Yeah, this was the pretty much clarity of what tech stack I was using, and yeah, whatever achievements, like I told, multi-threading architecture, basically, because there is not one system. We need to have asynchronous calling, because there might be a depth precision request also on the same time, and also a motion gesture precision also we need to do. So we need to do this in multi-threading architecture, right? So yeah, it was built on multi-threading architecture and hybrid AI approach, like combining traditional CV, मतलब open CV, and generative AI for robust guidance. So, and there was also continuous context updating systems. Yeah, and yeah, this was the pretty much of development achievements whatever I had built over there. Yeah, you can head over to this. You can. I guess I'll type this in. Yeah, the whole code is available on this GitHub repo. I guess you can take this from here.
So thank you. Great.